My name is Mahdi Dagmachi Firuzjai, and in this lecture I will explain the code injection attack. I will show you the main idea, some example of the code injection, and how we can mitigate against this kind of attacks. The code injection lecture is a part of the software security course. Basically, the code injection is a kind of attack which the attacker try to inject some malicious code into the program, in which the application interpret and execute this wrong code. Basically, the attacker try to take advantage of inadequate input-output data validation. For example, the lack of defining a class of allowed character, some whitelist characters, lack of restricting data format, lack of checking the amount of expected data, lack of restricting the data type are some example of inadequate data validation. So based on this vulnerability, the attacker can take or can launch the attack into the system. So the data validation is the main reason for to be successful or unsuccessful to launch an attack. Generally, by the code injection, the attacker tries to deceive the application to interpret or execute the some malicious code. Basically, the code injection can be launched in different environment and has different impact for example, in the web level, application or database level, or operating system level. As shown in this figure, you can see that by the client browser, the attacker can send or inject some malicious code to the web server, to the application. So based on this the server, the attacker can launch the database of the application by sending some example of that. It can be mentioned the SQL injection attack, or also in some cases the attacker can access to the operating system, to the OS. So by sending some malicious command to the OS, the attacker can launch some dangerous activity on the operating system. In the web level, nowadays, to perform the better functionality, most website perform some embedded dynamic contents in the web pages. Basically, we have two kind of the web pages: static web page and also dynamic web page. A static web page is made of the fixed code, and exactly the amount, or the page is fixed and with no change. But in the dynamic web pages, the user is able to have more interaction. For example, leave some comment, create a user profile, or make a reservation, etc. So for the first activity for this course, I ask you to take a look about the difference or the similarity between the static web page and the dynamic web page. For the next lecture, please provide your answer for this question: how we can detect this page is a static web page or the dynamic web page, and basically what is the main difference between these two type of the web pages? How can we make them, how can we change them, and how can we interact with these web pages? The dynamic web pages also is more user friendly, but are vulnerable to cross-site scripting code injection. Cross-site scripting, or XSS, is a kind of activity. So in this case, the web application gather information from user from other hyperlinks. So in this case, if the attacker is able to add or inject the malicious code in the hyperlink, the application will execute the link by included in the hyperlink. So in our daily activity, the user try to click on some links on another web pages to pop up the new page, or go to switch to another page, for example in the email or in some other web pages, is very normal. Based on this, the attacker, the malicious attacker, can embed the malicious portion of link and encode with some encoded method like hex. So in this case, the client cannot detect any malicious or any abnormality in the link. Based on this, the web application collect the data, also the wrong data, and create an output page for the client, for the user. So this kind of basically the XSS technique can be used to inject into the JavaScript programming, Visual Basic script, ActiveX, HTML, Flash, or other type of the web browser execution. The possible impact of this kind of the attack is that the attacker is able to hijack the account, change the user setting, and stealing the cookies and make them poison, or false advertisement, send the false advertising to the users. In the application level, the new web applications make the client able to have more interaction. For example, in the university web page, you can search some special persons, professor, the clerk, or you can search some special topic on the internet or on the intranet of the university. It's very normal for for the nowadays web application. These applications are based on user supplied data. The user enter the data, and based on that data, the application try to make the query, try to make the search. So in this case, the malicious command or malicious code can be injected or can be entered to the web application and by the client. So in this case, this malicious code is passed to the server to affect the execution of the predefined queries. By this attack, as a successful attack, the attacker can read sensitive data from the database, from the application database, modify database data, or execute some administrative operations within the database. For example, shut down the database manager system. SQL injection is a common and well-known techniques for this kind of the attack. As I mentioned initially, we have three kind of environment for the code injection. The third level of that environment is the OS level. So in this case, some shell application would based on the user supplied input to select a program or to select a command or the argument for the program. So in this case, the user will input the data to select the program or to select the command. Any web interface that does not properly sanitize the input would be vulnerable to this kind of the attack. By this kind of attack, the attacker can execute some OS command. So in this case, the attacker can inject unexpected or malicious command to OS, upload malicious program, or obtain password or any sensitive information directly from the operating system. So in this case, I try to explain the main idea and the impact of the code injection with different environment of the victim system. So to have more practical view of the code injection, in this part I will try to show some demonstration example of code injection based on four main programming language: Python, JavaScript, Perl, and Rust. Basically, the Python programming language has some functions which are vulnerable against injection attack. Mainly 5 functions: execute, exec, eval, exec file, input, and compile are the main vulnerability of Python programming language to code injection. For example, the the exec is a dynamic execution of Python code, accept the string as the input and try to interpret the string for execution. Same eval is return the value of an expression or code object entered by the user in the string. So they try to interpret the string argument, returning the result value. Exec file similar to exec, but in this case they read and execute Python script from a file, not directly from the input. And it try to execute the text as a statement. Input a string. In the Python version before Python 3000, this function is similar to eval, raw input, reading one line from the standard input and evaluate that as an expression and returning the result. Compile is a function, compiles the source string into an executable object. These main five functions are the main vulnerability of Python programming language to code injection. In the next slide, I will show you two examples and mitigation of this code injection problem with Python programming. The first example is a simple Python code to implement a basic calculator. Basically, the user try to input the values by and the function accept by input function. The input function reads the line from the standard input, and eval function perform the evaluation of the expression. In the top figure, you can see that the code, the script of the Python script, and in the bottom you can see that the result. I ran the script, and you can see the result. I entered the value, for example, 63 multiplied to 56 minus 120, and the result is this one. The eval try to evaluate the expression and find the result of that one. So the eval function evaluate the input, and it can calculate the entered value. Okay, it's fine. But what would happen if instead of this normal value and computational operation, I entered a wrong or a malicious code like this? Import os.system rmrf, etc. It's a very dangerous command, because import function is a Python function, dynamically import the module named by the string provided, and you can see that the OS system function invoke a shell to execute a command. This command rm-rf. This command is a OS command to delete file system root from the system. As you can see, there is no evaluation, there is no restriction, and there is no condition to accept the input from the user. So any code entered in the comp will be accepted and interpreted by the eval function. This is the main vulnerability. In the second example, I show you two examples of the function to set a name entered by the user and assign this name by the setName function. The setName function assign the value to an attribute. Both application in both script, both program, you can see that they both perform the same task, assign the name entered by user to an attribute. But the main difference is here, the setName. In the first script, the setName is used directly to accept the input from user and assign this name to an attribute. But in the second code, you can see that the setName is used indirectly by exec. So by the exec function, the user any input entered by user as a first name is assigned to the setName function. So the setName function is used indirectly. Similarly to the previous function, what would happen if the if the client entered a malicious code instead of a normal name or in the or standard name, standard characters. So in this case, you can see that what would happen if the malicious client entered some malicious code like this: sub process.call, again same command, rmrf. In this case, this command will destroy the server's file system. For mitigation, for this one, for mitigation, it's recommended that use directly set name, not used indirectly by the exec function. To mitigate the first example, in this case, you can see that instead of accept directly the input from user, we can perform some validation before accept the user's input. So in this case, you can see that we can provide some whitelist for the input. So at first the code try to validate the input from a user. If this input satisfies some whitelist or some condition, predefined condition, then the code try to print the result of the input as for the eval function. For example, in the whitelist, we can mention some valid numeric characters or arithmetic or computation operation like sum or multiplication. Or in the for condition or from restriction, we can make some condition for the accepted characters or escapes to detect some special characters used by the malicious code. These are two examples of the mitigation for Python code.